Hey guys, Chapter 9, Section 5, Video Part 1. So we're going to show you how to solve rational or fraction inequalities. As you can see by the box, it's kind of a pain. It's a long, tedious process, 5 steps to do. But it is similar to solving the equations, and it involves a number line, which you guys have done in the past. So hopefully not too bad. So let me scooch this up so we can see that first problem. All right, number one, right off the bat, I would recommend doing this first no matter what, so you don't forget. We have talked about restrictions. Restrictions are the number or numbers that you may not use in a problem based on the denominator. We can't have 0 in the denominator. So I see an A right down here. I see an A right down there. Well, what number, if I plug in there, will cause me to have 0 on the bottom? If I multiply 4 times 0, I get 0. If I multiply 8 times 0, I get 0. I can't have A equals 0. So establish that. That's step number one. We'll tell you what to do with that here in a moment. Step 2, solve the problem as if it were an equation. And we just did equations in the last section. So that's what I'm going to do. And I'm going to come up with common denominators because we're doing addition of fractions. So if I were to multiply this first guy by a 2, I'm going to have an 8a. If I have 8a for the first one, I already have 8a for the second one. I wouldn't have to mess with him. So I can multiply this third one by 4. That would give me an 8. So as long as I throw in an a, I now have an 8a on the bottom. The key, don't forget to do that to the top. So the top of the first fraction is now a 2. The middle fraction I never messed with, so he's still plus 5. And it says treat it like an equation in the directions, so I'm literally just going to make that an equal sign. So you might be saying to yourself, well, wait a minute, how do we just get to magically forget about the greater than less than sign? And we'll show you how to take care of that here in a minute. Third fraction, 4a times 1 is 4a. And what we're left with, relatively easy to solve. Total those guys up. I'm going to divide both sides by 4. And I get a 7/4 or 1.75 if you want to go decimal, which is fine. So that's step 3. Step 3, I'm sorry. Create a number line with a solution in the restrictions. So here comes my number line. I have a restriction of 0. I have a solution of 7/4, so they're on my number line. And in step 4 says to test values from each section of the number line. So we're going to shortcut this. You really only have to test one section, show you why in a second. I could test any number I want. I could test a number down here in this section of the number line, but that would be negative, makes it a little tougher to test. I could test a number clear up here, something bigger than 1.75. I could test 2. I could test 10. I could test 100. I could test anything I want. But just to make life as simple as possible, I'm going to test the number 1, which falls in between there. Because if I plug 1 in the problem, it'd be relatively easy to do. So clear up here in the left corner, I'm going to go ahead and squeeze that in. So remember, we test numbers. You test them in the original problem. And the original problem said, come on now, 1 over 4a, plugging in a 1, plus 5 over 8a, plugging in a 1, is greater than a half. So I'm not going to ignore that greater than sign now. So I have to figure out whether this is true or false. Well, I got 1/4. I got 5/8. I got a half. So you definitely have a calculator in which you could figure out what 1/4 plus 5/8 is. But I'm going to tell you right now that 5/8 is more than a half already. So if I add a 1/4 to it, it's most definitely going to be bigger than a half. So that statement would be true. So where did I test that number? I tested that number right in here, the number 1, which falls between 0 and 7/4. So that would be true. Okay, for our purposes, this doesn't always hold true. So you might have to test a number down here in this section to see whether it's true or false. You might have to test a number up here. But for our purposes, I'm going to tell you right now, they go back and forth. So if the middle guy was true, then he would skip down to false over there. And this guy would be false up here. So if I did test a number, if I tested -1, I'm telling you right now, he'd have been false. If I did test a number up here like the number 2, I'm telling you right now, it would have been false. So for our purposes, we get to shortcut and go back and forth. False, true, false, true. So that was step 4. Step 5, write a solution set based on the results. So I'm going to go with interval notation. And interval notation was the one that's written with brackets and parentheses and looks a little like coordinates. So I'm going with the parenthesis, and the reason I'm going with the parenthesis is because the problem itself said greater than. It didn't say greater than or equal to. So if we were to shade here, and it's never a bad idea, in fact, I'll go ahead and do that. We know we're using open circles, and basically you shade where the true answers are. So my answers range from 0 up to 7/4. That's where the shade is. And if you remember, brackets are for filled in circles and parentheses are for open circles. So that's it. That's the solution set for that guy. The other way of writing it, and if you feel more comfortable doing this, I will accept it, was inequality notation, which goes like that. And you really should put little squigglies around for set notation. So those mean the same thing. Either one's fine. I'm just going to go with interval notation from here on out. All right, problem number 2. Let me scroll back up. Show you step number 1 says determine the restrictions. So you really need to do that first. Well, this guy's the same as the last guy for all intent purposes. And I cannot have a 0 on the bottom because if I do, 3 times 0 is 0. That's a no-no. All right, step 2, solve the problem as if it were an equation. Well, if it's an equation, I need common denominators. So if I go 5 times 5 on that guy, I get myself a 15b. If I go times 3 on this guy, that'll also give me 15b. And this last one's missing a b, so I better put a b in there. And clean up the fractions. So we get 5 times 1 or 5 for the first one, minus 3 times 2 or 6 for the second one. Just going to treat it like an equal to problem. 1 times b is b, and I get to ignore the denominators. Why do I get to ignore the denominators? Can you answer that question? It's because they're common. If they're common way back, we learned that clear back at the beginning of school, common denominators we get to cross off and not even worry about them. So this one's even easier to solve. All I have to do is subtract over there. I got -1. So that was step 2, solve the problem. Step 3, create a number line. All right. So I got -1 for an answer. I got 0 for a restriction. And all I have to do is test a number from any section on that number line. Now, it does say in the directions test each section, but given this shortcut, and again, this is just for the type of problem we're doing, you get to go back and forth with your trues and falses. So easy number to test. How about up here? I'm going to test +1. You can test any section you want. Original problem. The original problem said 1/3b. So I'm popping in a 1. It said minus 2/5b. Pop it in a 1. Less than 1/15. So that's 1/3. That's 2/5. Less than 1/15. Well, if you do ring that up on a calculator, you're going to get a negative answer. Are negatives, so if this guy right here is negative, less than positives? Yes, they are. So we just determined that the number we tested in that section was true. So it's got to go back and forth. That means this guy's got to be false. That means that guy's got to be true. Okay, now I'm going to go ahead and shade, and I recommend that you do it. The original problem, again, did not have any equal signs, so we go with some open circles. I shade where the T's are. I shade where the true answers are. So this guy ends up, being shaded on the ends. And as far as interval notation goes, how do we write that? Well, this guy goes on forever. So -infinity. Infinity's always got the parentheses. Comma, stops at -1. No bracket. Picks up again at 0. And where does it go? It goes on forever to the right. And when we have a gap in the line like that, we learned before that means the union of two answers. So answer on the left, forever to the left, up to -1. Answer on the right, from 0, forever to the right. Put a big U in the middle for union, and there's your solution set. All right, guys, that is part 1. Looks like it's going to be 2 problems per section or per part on these videos. So please, there are 4 more problems to look at. Go ahead and take a peek at part 2 and part 3 videos if you get a chance. Thanks for watching.